Hi, everyone. Everyone seated? Awesome. So, thank you very much for coming. I hope you're enjoying the conference so far. And we're going to have up next Emil Stolarsky from Shopify. He's a production engineer at Shopify. He's going to talk to us about flash sales and how you prepare for flash sales, which is, I think, very interesting because it's always such a tough problem. Like, you don't want to book and you don't want to buy too much hardware on one end, and then you don't want to waste everything on the rest of the year, and you always have to test with double the load and whatever. It's very expensive, so it's kind of a bummer. So I'm really looking forward to hear how they deal with it. So thank you very much.
Hello, hi. So today I'm going to be talking about flash sales. So quick little bit about me. I'm a production engineer at Shopify. I work on the performance and capacity planning team. The team's goal is to optimize Shopify's response time and ensure the platform can sustain some of the largest flash sales in the world. A little bit about Shopify. Shopify is an e-commerce platform. It allows merchants to set up white label online stores and sell their products online seamlessly. If you bought something recently online and if it wasn't off of Amazon, chances are it was on a store hosted on the Shopify platform. So flash sales. At the most basic level, flash sales are limited availability sales, either in quantity or time. Another way to think about it is Black Friday. So quick show of hands, who here is familiar with Black Friday? All right, most people. So Black Friday is a shopping holiday where stores deeply discount their prices. It's considered the start of the Christmas shopping season. And on this day, people go absolutely crazy for these sales. They line up in the streets, they fight for products. So here's a video I found from a recent Black Friday. And so I asked earlier if anybody knows Urban Outfitters, but that's sort of like a cheap clothing store in North America. It's more than just the sale price that makes people go crazy. It's the whole experience. You get into the store, you make it to the rack, you get the product, you then fight to the cashier, you're alive, you've checked out, and now you're the proud owner of a half-off DVD box set. That's the story you're going to tell your grandchildren. Now, imagine if you could take Black Friday and bring it online. And instead of waiting once a year, you could do it once a week. That's the power of a flash sale. So some notable flash sellers on Shopify are Kanye West with his sneaker line and his latest album. Shops that have had Super Bowl ads such as Goldie Blocks, Death Wish Coffee, and Bud Light. And Kylie Jenner of the Kardashian dynasty has a cosmetics line that until recently had weekly flash sales. So for merchants, this is a big deal. They can generate an enormous amount of wealth by leveraging these events. But for us as engineers, these are terrifying. Flash sales can send an order of magnitude more traffic to the platform, and they're checkout driven, so the traffic is write heavy. So we can't simply just put up a cache in front and handle all of the requests. To top it off, flash sales are high profile. Merchants will use social media and their mailing list to bring a lot of customers to the website. So whenever there's a problem, we get notified quite quickly. These are some tweets from an earlier flash sale that didn't go too well. As you can tell, people are quite vocal on Twitter. Very vocal. Very, very vocal. So before I talk about how Shopify solves flash sales, let's do a quick overview of how Shopify works. So over here you can see GitHub's merch shop, which is hosted on Shopify. Shopify tries to mimic a traditional Rails architecture, the goal being that if you wrote Rails code anywhere else, you can come into Shopify and write production-ready code on the first day. So when you're navigating the storefront, some requests will hit MySQL to read. Other requests will be served out of Memcache. If you add anything to your cart, that cart is saved in Redis. When that cart is then converted into a checkout, that's a MySQL write. And then as you're proceeding through the checkout, you constantly write to MySQL. When you submit your checkout, we start a background worker to pull payment processors and do order fraud analysis. Throughout all those steps, you're constantly writing into MySQL until the checkout is complete. So before you can solve flash sales, you need to use the right tool for the job. And for us, that tool is Nginx. Nginx is a web server made by a bunch of crazy Russians. It can be used for reverse proxying, load balancing, caching, and throttling. We use it as our edge load balancer. And so the key point here is it allows us to solve the problem of flash sales without doing open heart surgery on the rest of the Shopify application. It's also a robust piece of software. Nginx blows Apache out of the water in terms of performance since it uses an event loop rather than threading for handling requests. It was also written up from the ground up with speed in mind. It's used by Cloudflare, SoundCloud, and GitHub. To level up Nginx from a simple web server to the application load balancer that we have today, we use a module called OpenResty, written by AgentCH at Cloudflare. And OpenResty allows us, places a Lua JIT into Nginx, allowing us to write Lua scripts to modify and control the flow of requests going through the load balancer. We've used it to build an HTTP router to enable multi-DC, a caching framework, as well as additional logging. Now, when you initially get a high write traffic events, your sort of go-to response is going to be to try and optimize all the write queries. And we did that at Shopify. The first thing we did was we printed out every single query that was run during a checkout, put it up on a wall, and started crossing them off one by one until we couldn't optimize them anymore. But over time, we realized that no matter how many queries we optimize or get rid of, there's still going to be more traffic, and you can't get rid of all writes. And so what we realized at a certain point was we have to teach our platform to give off back pressure. So the platform has to say, hey, wait, I'm full, I can't take any more, I'm at full capacity, I can't handle any more requests, come back later. And we did this by implementing a naive throttle using a leaky bucket. So when we couldn't handle any more checkout requests, we would serve a throttle page that would say, hey, we got your checkout, we're going to handle it soon, please don't go anywhere. And the way this looked is a user would send a request to Shopify, a checkout request, and that would hit the load balancer, and the load balancer would say, oh wait, I'm out of capacity. The load balancer would then go back to Shopify and ask for a throttle page. It would cache the throttle page using the caching framework we've developed and serve it to the user. Now, the throttle page had a JavaScript snippet and meta refresh tags that would constantly poll the load balancer in the background, asking, hey, do you have capacity, do you have capacity? And then once the load balancer did have capacity, it would pass the request through back to Shopify. Shopify would start a checkout, and the load balancer would place a cookie on the user's session, indicating to the load balancer, hey, don't throttle this request anymore. So to the user, it looked like there was no checkout throttle at all. So we initially did this, and the platform was happy, but the users were not. What ended up happening is some people would, so take it, for example, a sale that would take 30 minutes. Some users would come in at the very start of the sale and be in this throttle page for up to, say, 29 minutes. Then somebody on the 29th minute would come and pass through immediately. They just got lucky, and when they hit the load balancer had available capacity. And so, as you saw earlier, we got notified of this quite quickly, and people weren't too happy. Instead, what you want is you want a queue. You want the first customers who come and try to check out to be the first ones that get served. But you also want to do this in a stateless manner. The last thing you want is to add another data store that'll be a single point of failure when the platform is pushed to its peak capacity. So I say stateless here with an asterisk. And the reason I say it's kind of stateless is because each load balancer has state internally, but there's no cross load balancer state. Additionally, every user was given a securely signed cookie that had the timestamp of their initial request to the checkout page. What we did was we decided to build a feedback system. So a quick TLDR on feedback systems. Picture a thermostat. Say you want to have the room be 25 degrees. The sensor in the feedback system, in the thermostat says, okay, the room is currently 26 degrees. It sends a signal to the air conditioner and says, cool the room down by 1 degree. The air conditioner does its thing, but there's also, say, wind outside, or it's chilly outside, and the room goes down to 24 degrees. Well, the sensor tells the thermostat, all right, it's 24 degrees. The thermostat says, all right, raise the room temperature by 1 degree. It warms the room by 1 degree, but then there's sunlight in the room, and so it goes to 25.5. And this constantly oscillates back and forth. So we wanted to do the same thing where the load balancers would decide what requests do we pass and what requests do we throttle. And to do this, we used the timestamp in the cookie and a lag delimiter. All requests that came in after the lag delimiter were considered low priority. They were instantly throttled. All requests that came before were high priority, and they went to the leaky bucket that we had. And so in this example, the leaky bucket would say have a capacity of 16. Keep in mind that since this was stateless across load balancers, the capacity of every leaky bucket was unique to a load balancer. So when we were setting the value, we had to calculate what the capacity was of the entire platform and then divide that by the number of load balancers we had. So during typical operation, all requests are high priority. The lag delimiter is at current time, and all requests hit the bucket, and they all get passed through, and the bucket never fills up. But then during a flash sale, the bucket fills up quite quickly. And the load balancer notices this and pushes the lag delimiter back. And the load balancer, what the feedback system is sort of optimizing for is how many requests are hitting the bucket. So it's going to optimize for the size of the bucket, so 16 in this example. And it'll constantly move the lag delimiter back and forth to try to hit 16. If it's passing more requests than 16, if more requests than 16 hit the bucket, all those requests would be throttled. And so during the flash sale, as the number of checkouts that are occurring oscillates, so too does the lag delimiter, until the flash sale is over and the lag delimiter moves back to current time. So at this point, you might be wondering, that's cool, but why spend all these engineering resources on building this technology when you can have engineers working on adding new features and trying to bring more customers to the platform? So rather than myself explaining, I thought I'd show you a snippet from Keeping Up with the Kardashians of the behind-the-scenes look of them selling lipstick.
It just stopped. No. Is it broken already? Oh my god, you guys. Is it our site or it's Shopify's site? It's the site. The site's down? Shopify can't get in. Yeah. This is so stressful. Let's get Ryan on the phone. Hey Ryan, I can't get into the back end of the Shopify admin. Can you?
I'm doing that right now, but the site is open. The VIP guy, he says you'll be able to log in once we remove the cache, so they're doing it right now.
Cache?
I think they need to clear theirs, and they need to clear ours too.
Okay.
Oh my god.
You're up? I'm up over here. Yeah. Okay.
So it hasn't crashed yet?
No. The customer's not experiencing any problems. It's just our end. Okay. So we're selling product.
Yeah.
So almost 30,000 people are on the site.
Amazing.
What's it saying on social?
Bam.
Bam.
Gotta keep improving your site. I got Cozy and Span Coco easy. It was such a pain last time.
I just posted on Twitter.
Go get it, honey.
We're up over 70.
So in the next scene, everybody in that room is crying. Like everybody. And so this is about Shopify's reputation. Early on, Shopify decided that we would build the names for ourselves by not refusing customers that sent us large flash sales. It's also part of our core value, which is building for the long term. If Shopify is going to try to become the #1 e-commerce platform in the world, we can't ignore flash sales. We're going to have to solve them. And if we're going to do that, why not solve it today? So, and this has actually paid off quite well for Shopify because it's forced us to solve scaling pain points in our platform before we hit them by the platform growing. But it's not just flash sales. Think about payments. Maybe you have a video game that causes a lot of write events, or maybe you have a celebrity that sends out a tweet or a large sporting event. In that case, Nginx is an invaluable tool in your tool belt, especially if you're using OpenResty. Additionally, you can't ever build your platform to have infinite write capacity, so you're either going to have to figure out throttling or queuing, depending on what UX fits best. So finally, if anything I've talked about here sounds interesting to you, Shopify is always hiring. We're mainly based out of Canada, but we also have remote all over Europe. Be sure to come out to our booth. One last shout out, we're doing talks on Wednesday on Shopify's architecture, as well as fuzzy testing the kernel. So be sure to go check that out. Thank you. If you have any questions.
For that entire process, why won't pub sub work? As in, user requests come in and some worker tasks just take those requests as they come. And if there's too many, then they just queue up.
So in that scenario, would you have the users polling a service that would, so how would that look? Because from the perspective of, this isn't sort of a service internally, we have to have clients that are polling, right? So in that model, what would that look like for the clients polling? Would they poll a service that then polls the workers?
Maybe, I don't know. Okay, so the issue is that clients client web pages have to pull your servers for the state, and if they're at the end of the sale and nothing's left, and they have to keep on pulling until, oh wait, you didn't actually get it.
Right. So moving to some sort of pub sub model would be it'd be different. So Shopify tries to always take like, hey, what's the simplest solution to solve the problem? And in this scenario, it was, hey, we've got this awesome ability to do scripting inside of Nginx. So if we can solve it in a manner that doesn't include or add too much complexity, and we can do it resiliently, let's just do it in Nginx. And so that was the path we took.
Okay.
Cool.
Thank you. Yeah, a lovely talk, and I'm really happy that I got to see the Kardashians.
Thank you.
My fiance will be very impressed.
We know the whole family tree. We've got books now. Come ask us a Kardashian question.
So a question about the lag indicator. So are you using this, because that wasn't quite clear to me, are you using the same leaky bucket algorithm to move the lag indicator around?
No, so for the lag indicator, we're using just a PID. And so we're using a constant that oscillates it back and forth. So the leaky bucket is just, we can serve, say, 16 requests for these 5 seconds. And then once that rolls over, we empty the bucket.
Okay, so I assume you have multiple load balancers, so
Yeah.
you trust round robin to keep the lag indicator in approximately the same location on all these machines.
So we use ECMP to distribute load on the load balancers. And so you roughly get the same amount of traffic on all the load balancers.
Okay, and then,
so
and
it's
then
roughly equal. When we graph internally sort of what the lag indicator is or where it is, and it's more or less equal. Like they don't skew away from each other enough for us to have to go and solve that problem.
Right. Okay, thank you. I mean, I really like the solution. I think it's really awesome. So
Thank you.
Thank you.
Any other questions?
So you talked a bit about in the throttling initial solution that the UX was like not so friendly.
Mm-hmm.
And I was curious, like, how is that different now with the queue situation if you come in after the
given that we have the lag delimiter,
Yeah.
you also have the timestamp. So if your timestamp, every time you hit a requested load balancer, we'll check what the timestamp is. And if you came in later, your timestamp will ergo be later. And so you'll be falling into the low priority bucket until the lag delimiter moves after, and then you become high priority, and then you hit the...
Right, but you still have to wait around, right?
Yes. So what we're optimizing here for is first come, first serve versus first come, maybe get served. And so the difference was we saw initially the P95 of waiting in the queue was almost equal to the duration of the sale. And then afterwards, the P95 hovered around a few minutes in the context of, like, say, a 30, 40-minute sale, which was like a drastic difference. And we saw quite drastic response from the customers.
Cool.
All right. Thank you.